15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you, as always, for joining us on the Space Nuts podcast. My name's Andrew Dunkley, your host, and with me is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you doing in dusty Dubbo?
Very, very dusty, very, very windy, very, very dry, very, very nasty. I got in the car the other day after one particular dust storm, and I went to clean the windscreen, and I usually hit the washers first and then the wipers, and I did it the wrong way around, and you should have, it just went... And then I hit it with the water, and this big mudslide went down my windscreen. It was terrible.
Yeah.
Oh, it's just horrible, Fred. I don't know when we'll ever see an end to this. We've been in a drought for probably 2 years now, and it just gets worse and worse and worse. We've got animals coming into town looking for food and water that you just don't see. I saw an echidna the other day. Mm-hmm. We've got kangaroos living on the streets. Mm-hmm. In some parts of town, I wouldn't be surprised if soon we start seeing emus and maybe some camels, because they're running out of things to eat and drink, so they tend to move to wherever the green grass is. And look, there isn't much of that here, but it's just a real mess here at the moment, and everyone's struggling. It's really depleting the economic movement of the town.
How is the Western Plains Zoo coping?
The other thing that's sort of hurting us is tourism. We're just not getting people coming out here.
Yeah.
And so the zoo's numbers are down, tourism numbers are down significantly this summer. And it just all adds up to one big pile of doo-doo. It's not a nice place to be at the moment, and I would never say that about where I live. I've been here 25 years and I love it, but right now it's just like something out of an apocalyptic movie. You look at the sky, and just about every other day it's orange. If it's not orange, it's sort of blue with smoke from the fires. We have probably one clear day a week, and that's become normal this summer. And adding to that, the number of temperatures over 40 degrees Celsius, we've had more this summer than I can ever remember. And we had like 4 or 5, maybe 6 in a row there a few weeks ago, with numbers up around 46, 47 degrees. It's just horrific. The good news is the climatic models are starting to work back in our favour. One of the big things that affects the weather here is the Indian Ocean dipole, which is the surface temperature of the Indian Ocean. And for a while there, it was like 4 degrees above average, which is, means dry weather. And that has just in the last couple of weeks plummeted back to normal, which means we may start to see normal weather conditions return. And that's been evidenced a bit with some specks of rain here and there. But where it's so dry, you get one frontal system through, and you just get this big wall of dust that hits you like just a brick wall. It's just impossible to try and describe it to people. And then you show them the photos, and they go, "Oh my gosh, how did you get through that?" You just got to. But it's getting into the air conditioning. It's getting into houses. It's getting into car systems. It gets into your eyes, your throat, your nose. It gets all through your hair. It's just, honestly, I don't remember any other year like this. I've seen dust storms before. I've seen locust plagues. I've seen it all out here. This is the true country. But this year they've kind of thrown it all together. Even the locusts are complaining. So it's pretty hideous.
Yeah. Well, we all know why it's happening.
Yes, we do. And yet there are still those who deny it. But I think the evidence is far beyond reasonable now. Yeah. Let's get on to some more...
on that happy note.
Let's get into stuff that's not of this world, let's say. And the focus today is on Australia, because we've got 3 stories about Australian astronomical situations or events or even awards. Now, one of them is about a planet that's been discovered. Another is the oldest impact crater ever found, and that is in Australia. And one of our Aussie astronomers is to get a major US award for the first time in about 5 million years, I think. So we'll look at all of that, but we'll start off, Fred, with TOI-257b, and this is a weird planet because if there was an ocean big enough, it would float.
Exactly, just like our own planet Saturn, which would also float.
Oh, would it? I didn't know that.
Didn't you know that? Oh, well, there you go. Saturn's density is less than that of water, and it has that in common with TOI-257b, which is being called Queensland's planet. So that's why this is an Australian story. It is a planet that was first detected by the TESS spacecraft. I can't remember what TESS stands for. It's terrestrial transiting exoplanet survey satellite. Get it right, Fred. The transiting exoplanet survey satellite is TESS, and that spacecraft does what the Kepler spacecraft used to do. It looks for dips in the brightness of stars that betray the presence of an orbiting planet. So TOI, and I think that's something like target of interest. I think that's what it means. It's a test term. TOI-257b basically was revealed by the TESS spacecraft, but followed up by telescopes in regional Queensland, not very far from the city of Toowoomba, which is a beautiful place.
Oh, it is.
On the highlands there, on the Darling Downs, and not very far out of Toowoomba is a mountain called, well, it's a hill really, but it's called Mount Kent. Mount Kent, for a long, long time, has had an observatory operated by the University of Southern Queensland. I've had a little bit to do with that observatory from time to time because I am very happy to have a close connection with the University of Southern Queensland. I've got an adjunct appointment there, which I'm very proud of. Yes. So Mount Kent is it's on a good site and has now state-of-the-art equipment, an array of 5 70-centimetre, what's that? That's kind of 38 feet or thereabouts, something like that. Robotic telescopes. They're big telescopes, by these sorts of standards. And they're part of a project called Minerva Australis. So this is the Southern Hemisphere version of Minerva. Minerva 2 is an acronym, but I can't remember what it stands for. Never mind all that. The news is that with the Minerva follow-up of TOI-257b, it's not just a discovery. This is learning about the physical features of this planet. And as the lead author on the paper that's reported all this, Dr. Brett Addison from University of Southern Queensland, basically he said, this is a significant discovery, not just for USQ and Queensland, but as an example of cool and unusual planet types. I think by cool there he means interesting rather than low in temperature. TOI-257b is an example of what astronomers call sub-Saturns, and they're planets that are larger than Neptune and smaller than Saturn. And of course, there aren't any examples of that within our own solar system. It's as Brett says, the universe is a quirky and diverse place with broad classes of planets such as sub-Saturns, super-Earths, and mini-Neptunes that we don't have here at home. Warm sub-Saturns like TOI-257b are rare among the currently known exoplanets. And that's true, actually, of all these slightly odd things, the super-Earths and the mini-Neptunes. These are fairly rare categories, so that the two categories of planet that we find in our own solar system, which are basically small rocky planets and large gas planets, they are really the commonest classes of planets that we find out there in space. And things that don't quite fit into that, whilst they exist, are rare. And so TOI-257b is one example of one of these rarities. So this is, it's a great story. It's great news. The fact that we now know its density is less than that of water, that marks it out as being something pretty interesting.
Yeah.
But there's more to come, I think, Andrew, because the authors of this paper suggest that their data shows strong evidence for a second planet in the system, TOI-257c. Yes, that's right, and they hope to confirm that within this year. So we will, we'll hear more about this. I'm sure from University of Southern Queensland. As I said, it's a great Australian story. The two more comments made by the authors of this paper: the cloud tops of this planet are not particularly cool. They reach at least 1,300 degrees Celsius, which is certainly more than the cloud tops of the Earth. So it's probably not that habitable a place. And there's an in-joke here as well. It may be a Queenslander, but forget calling it Planet Maroon. The maroon's the colour of Queensland. It's one of these silly sporting things, isn't it?
Yes, maroon is the official sporting colour of Queensland.
Thank you.
And sky blue is the official sporting colour of New South Wales. Forget calling it Planet Maroon. It can only be officially named, as can all bodies in the universe, by the International Astronomical Union. Probably most of the universe doesn't know about that, but certainly on Earth, the International Astronomical Union is the place where things get named. Well, to be honest, if the Queenslanders were going to give a planet a name, it wouldn't be Maroon, it would be Wally or something like that, named after their most famous footballers.
There you go.
I'm pretty sure, yes. Now, there's another twist to this little story, is there not? Or am I getting it mixed up with another story we're yet to do?
Well, one of my colleagues at USQ, whose name is John T. Horner, a fantastic science communicator himself. I often hear him on the radio. His mother is one of our fans.
Hey, hello, Mrs. Jonty.
Yes, well, that's right. And she lives. She lives on the Isle of Skye in Western Scotland, which is an absolutely enchanting place, especially when it's not raining. Of course, the west of Scotland is traditionally a wet part of the world, but Skye is lovely. And so, to be honest, I think you would be well advised, Andrew, to be envious of Jonty's mum on the Isle of Skye.
Well, if she's getting rain, I am envious.
Yeah, given what you're putting up with every day.
Yes, indeed. We are quite the opposite at the present time.
That's right.
Well, that's wonderful. All right. So maybe more to learn from the Minerva program in Queensland. This is Space Nuts with Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, I'm pleased to say that our numbers on YouTube are rising rapidly. And I can see we're not at 1,000 yet, but I would envisage by next week we probably will have tipped the scale.
Way.
But we're moving up rapidly. So if you would like to follow us and subscribe on our YouTube channel, you can do so by just doing a search for Space Nuts on YouTube. I think you'll also find a really old, terrible sci-fi movie named Space Nuts too if you search in the wrong place. But youtube.com/c/Space Nuts, you'll find us and subscribe, and you can listen to everything there.
Including the movie.
Yeah, including the but not the bonus material. That's available via Patreon. We'll talk about that later. But YouTube, we're ever more encroaching on the 1,000, which is fantastic. Now, keeping the Australian flavour of this week's podcast going, Fred, there's a place called Yarrabubba. It's an impact site in Western Australia, and they now think it's the oldest impact site on Earth, which is rather fascinating.
That's right. And in fact, it's the dating that has been done on this impact site, and by that I mean dating of the rocks, not dating of people, has a really staggering precision. I'm really impressed with the results that are coming from this. Yarrabubba, it's in Western Australia. Pretty well central in the state of Western Australia. I don't know, I would guess, several, probably 800 or 900 kilometres from Perth. Probably not that far, actually, from the Murchison station where the square kilometre array is being built. So in that neck of the woods. And of course, that is an extremely stable landscape geologically.
It is quite ancient landscape.
That's right.
For those who are unaware, that may live beyond our shores, Western Australia probably takes up around 1/3 of the continental mass of Australia. It is a huge state, massive state.
And a lot of it is, really stable and ancient pieces of Earth's crust. We find, for example, in further north than where we're talking about now, we find rocks that probably bear the evidence of the very first life that formed on Earth. These are these microbial mats called stromatolites. But that's not what we're talking about. What we're talking about is a place where an asteroid, probably a moderately sized asteroid. I think we're talking about, several tens of kilometers here. This thing hit the Earth. It produced a 70-kilometer diameter crater on Earth. But the evidence of that crater now is kind of buried, if I can put it that way. And that's partly because the Earth is a very dynamic planet. We've got weather erosion, and so structures like impact craters, unlike on the Moon, where there are many craters much older than this, that the impact craters on Earth get eroded down by weather processes. And actually, on most of the Earth's surface, they've disappeared because of plate tectonics. The rocks which bear them have disappeared underneath the nearest continental plate. As I said, though, this is very ancient rock here in Western Australia. And the way you tell that there is an impact crater there is basically by studying the geology. You can tell that there are slight gravitational anomalies, and that you can look for the kind of crystals that get produced by high temperature impact around the boundary of what would have been the crater before it was eroded away. So the evidence that there was an impact here is very strong. But what's new, and the reason why you and I are speaking about this story now, is the dating of this crater. And that is basically results, or it's research that has come from studies of the crystals that are within the rocks that were impacted by whatever it is that hit them. Things like zircon crystals, which can be used as clocks to work out when an impact or when there was a shock passed through them. And these zircon crystals have allowed the dating of the Yarrabubba Crater to within an accuracy. I did look this up actually in the original paper, but I don't have it in front of me. But I think it's the accuracy is 5 million years. Now that sounds like a lot, but the date is 2.229 billion years ago.
Wow.
So you're looking at an uncertainty of of 5 in the last number of that. 2.229 billion years with very high precision. Why is that? Why is it a record breaker? Because the what used to be the earliest known asteroid strike, which is in South Africa, actually, that was actually 200 million years later than this. So around about 2 billion years ago. So that pushes back the record for the earliest known impact structure on Earth back to 2.229 billion years, which is round about half the age of the Earth. The Earth is about 4.6.
So what would Earth have been like 2.2 billion years ago?
That's where it gets even more interesting, because the Earth has gone through a number of periods. I think there are thought to be about 5 of them when it was basically a snowball. It was covered in ice.
Okay.
The atmospherics were such that all water on the surface was frozen, and the planet was basically covered. It was covered in ice. It's sometimes called snowball Earth because of that, as I just said. But I think it was one of those icy periods came to an end round about 2.229 billion years ago.
Oh.
And so the bow that the authors of this paper are drawing, and I think they're based, I think the principal author is based at NASA Johnson, the Johnson Space Center in Houston. The bow that they're drawing is that perhaps this impact lofted enough water vapor into the atmosphere, and maybe carbon dioxide as well, to change the climate. And in other words, to bring the icy period to an end, this period of mass glaciation. There are people who are saying that's too long a bow to draw, but it does look as though that's a reasonably interesting, at least, explanation for that perhaps whatever clouted the Earth at that time was basically the thing that caused the Earth to switch climate.
Wow. So some are saying that's an absolute, some are saying that's a partial reason, some are saying, nah, something else did it.
Well, yeah, that's right. There's some scientists are actually fairly, a bit skeptical about that. Basically, there is some criticism of the modelling being speculative. And one of the criticisms is that if you throw up a lot of water vapor or carbon dioxide into the atmosphere, the climatic effect doesn't last for all that long. And so, is that enough to end this global glaciation phenomenon? The question is, that's a question that we don't have an answer to. But I think all the people who are critical still think it's quite neat research, and especially this dating of the crater with such high precision.
Yes, indeed. And unfortunately, it's a very isolated place and very hard to get to, I would imagine. Or even if it's easy to get to, it's a heck of a long trip.
It's a long way, that's right.
So if you want to go and look at it, I think photographs are probably the best way to go. It just looks like the typical arid interior of Australia, really. Actually,
yes.
It looks a lot like Dubbo is looking at the moment.
Yeah, actually, well, yes, I suppose that's true. It's certainly very brown.
Indeed. Okay. So we may learn more as time goes on. These studies are ongoing, a lot of the things we talk about, and occasionally we can revisit them when more information comes to light.
Indeed.
This is Space Nuts with Professor Fred Watson and Andrew Dunkley, of course.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, once again, reminding you that you can support the Space Nuts podcast by becoming a patron, and you can do that at our Patreon website, patreon.com/space nuts. You can spend $3 a month, $5, $10, whatever you like. Some people have chosen to spend more, and that is wonderful. Thank you. It is not mandatory, but as a patron, we are offering bonus material every week, which is building up rather nicely. We're also offering you an early access edition of Space Nuts commercial free. So that is what's on offer for patrons. Patreon.com/space nuts if you'd like to check it out. If it's not for you, that's fine, but the option is there. Now, Fred, we normally answer some questions at this time, but this week we want to talk about a rather wonderful award that is being given to an Australian astronomer, and this is the first time in many, many years that such an award has been offered to an Australian.
It's the James Craig Watson Award. Nothing to do with me. It was named after an American-Canadian astronomer and has been presented every 2 years since 1887 by, I think it's the National Academy of Science in the USA. So the James Craig Watson Medal is something that recognizes scientists of very high distinction, and as I said, US National Academy of Science. It hasn't ever been presented to an Australian. And in fact, it hasn't ever been presented to somebody in the Southern Hemisphere. So this is the first time it's gone to somebody in our country. And its recipient is very, very worthy of the honour. The recipient is Professor Lisa Cooley, who is, a job title is quite extensive. It takes a while to read.
It's a couple of pages.
A professor and Australian Research Council Laureate Fellow at the Australian National University. That's in Canberra, of course. But she's also director of something called the Australian Research Council Centre of Excellence in All-Sky Astrophysics in 3 dimensions. It's usually known as Astro 3D. I've had a fair bit to do with Astro 3D on and off over the years that it has existed, but Lisa directs it. And what this is all about, so all-sky astrophysics in 3D, of course, is basically looking at the whole sky, but with the additional dimension of distance in there. And that doesn't just mean the distance is 2 objects, it means galaxies as well. So what she's done, and Lisa has a whole, track record of awards and fellowships, but she is an established world leader in the theoretical modelling and observation of star-forming and active galaxies. Her seminal contributions, and I'm reading now from the press release, include understanding the gas physics in such galaxies, understanding galaxies containing actively accreting supermassive black holes. That means black holes feeding on the stuff around them, as you know, of course, Andrew, and tracing the star formation and oxygen history of galaxies over the past 12 billion years. So it's big picture stuff.
It is.
And of course, that feeds directly into our understanding of the way the universe has evolved, the way our own galaxy has evolved. So she's done a lot in modelling how these things take place. The theoretical modelling, as I mentioned a minute ago, that's basically been what she's done, and those models fit extraordinarily well to what we observe in the universe. So it's great stuff, and actually, almost single-handedly in some ways, she's transformed the field. One of the other Lisa's accolades is that she was one of the Astronomy magazine's top 10 rising stars in 2009. And she appeared on national documentaries for the Discovery Channel and the National Geographic Channel. So this is a person whose trajectory has been very steeply upwards, and I'm really not surprised that she has received this medal, but it is delightful that she, becomes the first person in our hemisphere to get it, especially because one of her passions, of course, is, women in STEM and similar educational activities. It's bringing the kind of science that we do to as broad and as diverse an audience as possible, and to encourage people from all backgrounds and all ranges of diversity to come in and become scientists themselves. So she's really an inspiring figure in Australian astronomy.
Now, question without notice, it's the James Craig Watson Award. Do you know much about James Craig Watson?
Only that he has a name very similar to mine. I have a son called James Watson.
Oh, yes, you do.
Yes, I do. I should have checked up on that because I don't actually know what James Craig Watson did. He, as I mentioned, is an American-Canadian astronomer. To set up a bequest of an award, you need to be fairly well-heeled. A lot of astronomers
that's why
are
I brought it up, because I thought, this is an award that comes with, a couple of dollars attached to it.
Yeah,
$7.50, and it. Are
those US dollars or Australian dollars?
Probably US dollars. I wondered where he amassed his fortune. So
I will try and check up on that, Andrew.
Yeah, but obviously a very successful man in his time, and we're talking like middle of the 1800s, basically, when he was around doing his thing. and highly successful. So, what a great award and what great success for her.
So I've now followed up on your question.
That's
Can answer it.
That's an old radio trick called padding.
Yeah, well done. Let me, because the press release actually has a note about the James Craig Watson Medal, which is very nice.
Handy.
It is handy. The James Craig Watson Medal is presented every 2 years for outstanding contributions to the science of astronomy and carries with it a gold-plated bronze medal.
Ooh.
A $25,000 prize, never mind this $7.50, Andrew, and $50,000 to support the recipient's research. The Watson Medal was established by NAS member and prolific Canadian-American astronomer James Craig Watson. Watson is credited with discovering 22 asteroids in his lifetime. He published many articles and wrote a popular treatise on comets in 1861 and theoretical astronomy in 1868.
Isn't that wonderful?
So, yeah, a notable person, and what a great name. I do like that surname he's got there.
Yeah, funny that.
Yeah.
All right. That is wonderful news. We'll get back to questions next week. We just thought we needed to recognise such a great achievement from someone who's obviously very, very passionate like you, Fred, but has really made some inroads into some of those areas, those massive areas of astronomy that we so often talk about. So
that's right.
What a great effort. And that'll wrap us up for another week. I will remind people, however, that you can visit the Space Nuts shop at our website, bytes.com/spacenuts, and pick yourself up a T-shirt or maybe a book. There's a couple of nice books there by one Professor Fred Watson and some other joker. But, have a look. And
there's one about golf there, isn't there?
Yeah, 5 Irons Don't Float was one of my experimental books. I wrote this tongue-in-cheek sports psychology book just for fun. It took me about an hour and a half to write it. But it's based on my gathering of knowledge through stories I've done on sports psychology and a lot of books I've read on sports psychology, particularly focusing on golf and how to think and how not to lose your mud playing the game. And I thought, well, I know this has been done before, but I'll write a rather tongue-in-cheek, somewhat bawdy version of a sports psychology book and really take it down to the bottom of the barrel. And it worked. Right, it's only about 50 pages, but it's aimed at golfers who basically lose their tempers and how not to. Sadly, as the author, it didn't work for me, but it'll work for somebody. No, it was just fun. It was an experiment to see how I go publishing an ebook, and I just wanted to do that and see if the process was worth pursuing, and it turned out all right. And the cover is my 5 iron sitting at the bottom of a lake.
Righto.
Yeah.
Which is what the planet Saturn wouldn't do.
Yes, exactly. Or planet TOI-257b.
That's the one, yes.
All right. Thank you, Fred, as always. It's been a great pleasure and lots of fun.
Yeah, no worries, Andrew, and we'll speak again soon.
We will indeed. Catch you next week. And from me, Andrew Dunkley, thanks again. If you're a patron, we've got some bonus material coming up for you very soon on our Patreon account. Otherwise, we'll catch up with you next week on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at bytes.com. This has been another quality podcast production from bytes.com.